All right, today we're tackling one of the biggest questions in AI development right now. How do you build a RAG system that's actually ready for the enterprise? We're going to cut through all the hype and focus on the real-world trade-offs that engineers and architects face every single day. So, let's get right into it.
You know, there's a huge assumption out there that if you're building a serious RAG system, you absolutely have to use a vector database. But I'm here to tell you that's not just an assumption, it can be a really dangerous oversimplification. And this gets us to what I like to call the enterprise RAG myth. The problem with this myth is that it assumes semantic search, just finding similar meanings, is the only thing that matters. But in a real business, the challenges are way more complex than that. So what really matters when you're building for an enterprise? Well, it's things like the structure of your data, how your users actually search for things, and of course, critical compliance rules. And let's be honest, it almost always comes down to budget and speed. These are the things that should be guiding your architecture, not just the latest tech trend. Okay, so if it's not always about vectors, what are your other options? Let's break down the two main architectural paths you can actually take when building these systems. So first up, we've got the one you've probably seen 100 times, vector-based RAG. A user asks a question, the system turns that question into a big list of numbers. That's the embedding. And then it hunts through a database to find other content with similar numbers. The whole game here is about finding semantic meaning. Now, let's look at the complete opposite, a non-vector approach. Here, instead of making an embedding, the system first narrows things down using metadata, like a product ID or date. Then it uses old school but super powerful keyword search, like BM25, to find exact matches. See the difference? It's way more deterministic and you're much more in control. All right, this is where it gets really interesting. Now we can get into the real trade-offs and compare these two approaches head-to-head on the stuff that actually matters when you're running a live system in production. The first big trade-off is all about precision versus recall. Think of vector systems like a giant fishing net. They're great for recall because they catch everything that's even remotely related to your query, but that can be messy. Non-vector systems, on the other hand, are like a specific key for a specific lock. They give you amazing precision, finding that one exact product code or legal clause, but they might miss things that use slightly different words for the same idea. Next up, let's talk about money. Vector RAG can get expensive fast. You're talking about building new pipelines for embeddings, managing specialized databases. It's a big operational lift. A non-vector approach? Well, that often just uses the SQL databases and search engines you already have, which can make it dramatically cheaper and simpler to get off the ground. And here's a huge one that people often forget: compliance. In fields like law or finance, kind of similar isn't just wrong, it can be legally dangerous. You absolutely need the exact wording, and vector search just can't promise that. Because non-vector systems are built on exact keyword matching, they are fundamentally safer for these high-stakes use cases.
So let's just quickly sum this up. Vector RAG gives you that wide net recall, but it comes with a higher price tag in both cost and complexity. Non-vector RAG, on the other hand, delivers surgical precision for a much lower cost. There's no single best answer here. It really depends on what you're trying to do.
Okay, so that brings us to the most important part of this whole thing. How do you actually choose? Let's move from all this theory to a practical guide you can actually use. Let's just ask the question straight up. Given how much they cost and how complex they are, when is adding a vector database just overkill? When are you just adding complexity for complexity's sake? Well, you probably don't need vector search if you find yourself nodding along to these points. If your data is already nicely structured and your users are looking for specific things like product codes, a non-vector system isn't just cheaper, it's often better. It's more precise and gives your users exactly what they're looking for. But look, it's rarely that simple, is it? What if you need both? What if your users ask broad conversational questions and they also search for very specific product names? How do you get the best of both worlds? And the answer is hybrid search. To be honest, this has become the gold standard for most mature production-grade RAG systems. It's all about combining the dense vector search for meaning with the sparse keyword search for precision. It's not about picking one or the other, it's about using them together. The basic idea here is that you run both searches at the same time and then cleverly blend the results. This way, you capture both the general meaning of a query from the vector search and the absolutely crucial exact keywords from the keyword search. Okay, but wait, this creates a new headache, right?
By combining two search methods, your recall goes way up, which means you get back a ton of documents. And let's face it, most of them are probably just noise. So how in the world do you find the real signal in all that? The solution is a really powerful technique called re-ranking, usually with something called a cross-encoder. It's a total game changer. After you've retrieved a whole bunch of potential documents, you use a second, smarter model that looks at the user's query and each document together and gives it a relevant score. This lets you pinpoint the absolute best results with incredible accuracy. And here's how that pattern works in the real world. First, you cast a wide net. Get 50, maybe 100 potential documents using your cheap hybrid search. Second, you bring in the expensive but super accurate cross-encoder to re-rank just that small set. And finally, you only send the absolute best 3 to 5 results to the LLM. This pattern is genius because it can save you a massive amount on token costs and it makes your answers way, way better. All right, let's put this all together into a simple, practical decision framework that you can take back and use with your own team. This really just comes down to having an honest conversation. You need to look at your specific situation and ask these questions. How structured is our data, really? How do our users actually search? Do we have strict compliance needs? And what's our budget? The goal here is to build what you need, not just what's popular. And here's the simple takeaway. If you found yourself answering yes to most of those questions, you should absolutely start with a simpler, cheaper, non-vector architecture. But if you answered no to most of them, then the complexity and cost of a hybrid approach is probably justified for your project. And that leaves us with the final, brutal truth of building stuff for the enterprise. Vector databases and embeddings are amazing tools, but they are not the automatic starting point. The best practice, the smart move, is always to start simple, measure how you're doing, and only add complexity, like a vector layer, when you have clear proof that you actually need it. Build for your use case, not for the hype.